Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. Today's puzzle is called Dots and Dashes by Da Costa, and here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3x3 box. Digits separated by a black dot are in a 1:2 ratio. That is, one digit is double the other, though these are called black Kropke dots. So for example, if this was a 2, this would have to be a 1 or 4 to maintain the 1:2 ratio. Digits in cages don't repeat and sum to the total in the upper left corner if given. So, for example, these 4 digits add up to 10. These 4 digits add up to 30. These 3 digits add up to 15. And remember, you cannot have repeats in these cages. So, as an example, this could be something like 3, 4, and 8, because these 3 digits add up to 15. And that's how killer cages work. But remember, you can't have repeats there. Digits separated by V sign sum to 5. So, for example, if this was a 1, this would have to be a 4 to make sure that these digits add up to 5. Not all dots and V's are given. That's it. Good luck and happy solve. And may I say, actually, Da Costa, excellent job with the rules. Da Costa, I don't know if English is his native language, but because there were some interesting spellings he oftentimes had and usage of grammar that weren't quite, well, they weren't typical of an English speaker. So these rules, excellent job. Excellent job of making a clear, spelled perfectly rule set. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we have 2 digits that are in a 1:2 ratio. Okay, so we have 4 digits adding up to 30. Those are 6, 7, 8, and 9. Well, 2 of them have to be in a 1:2 ratio. Apologies. Have to be in a 1:2 ratio with another digit. So only 6 and 8 satisfies that for 6, 7, 8, 9. Similarly, we have a 6, 7, 8, 9 here, which means this has to be 6 and 8. Well, 6 and 8 can only be in a 1:2 ratio with 3 and 4. So this is 3 and 4, this is 3 and 4. This must be 1 and 2 adding up to 1 and 2. These must be 1 through 4. These must be 1 through 4. Similarly, these are 1 through 4, and these are 1 through 4. Okay. What do we know about this? These cages are the digits 1 through 9. But this specifically cannot be 1, 2, 3, or 4 because of the 1, 2, 3, 4 quadruplets in the row. Similarly, this can't be 1, 2, 3, or 4 because of the 1, 2, 3, 4 quadruplet in the row. Actually, these can't be 1, 2, 3, or 4. All of these rows all these cells in rows 3 and 4 and 6 and 7 cannot contain 1, 2, 3, 4 because of the 1, 2, 3, 4 quadruplets in each row. So these are 5, 6, 7, 8, 9. These are 5, 6, 7, 8, 9. These are 5, 6, 7, 8, 9. And these are 5, 6, 7, 8, 9. Similarly, in columns 3 and 7, 3, 4, 6, and 7, you cannot have... Okay, that's interesting. Okay, so this also has to be 6 or 8. Because, okay, so let's remove the ones that we didn't necessarily have to have. This cannot be 1, 2, 3, or 4 because of the 1, 2, 3, 4 quadruplet in the column. So similarly, this can't be 1, 2, 3, 4 because of the 1, 2, 3, 4 quadruplet in the column. The only digits out of 5 through 9 which can be in a 1 to 2 ratio with anything is also 6 and 8 here, because 5 is not 5 doubled is 10 or more, so anything above 5 cannot be doubled. And if you try to get 5, if you try to double something to get 5, 7, or 9, they have a half in there, and that's not a digit. So this is 6 and 8, and again, 6 and 8 can only be in a 1 to 2 ratio with 3 or 4. So this is 3 or 4, this is 3 or 4, which means we have a 3, 4, 3, 4 pair in row 3 and row 7, which eliminates 3 and 4 in the rest of row 3s and 7. So this can't be 3 or 4, this can't be 3 or 4, this can't be 3 or 4, and this can't be 3 or 4. Well, because of these cells, we have a 1, 2, 1, 2 pair in this cage, which eliminates 1 and 2 in the rest of the cage. This cannot be 1 or 2, it's 3 or 4. Similarly, in this cage, we have a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the cage. So this is 3 or 4. Now, in this middle box, we have a 3, 4, 3, 4 pair, which eliminates 3 and 4 in the rest of the box. So this can't be 3 or 4. This can't be 3 or 4. In these cages now, we have 1, 2, 1, 2 pairs, which eliminate 1 and 2 from the rest of the cage. So these must be 3 and 4. Well, let's start coloring these cells. We're going to make this red and yellow. So this cannot be red, it has to be yellow. This can't be yellow, it must be red. Since this is red, this cannot be red, so this must be yellow. Therefore, this must be yellow also. This yellow means this can't be yellow, so this must be red. So we're going to correspondingly mark their 1 to 2 ratios. So this is yellow, this is yellow, this is red. This is yellow. So this pair, which is in a 1 to 2 ratio, cannot have a red 6, 8 or a yellow 6, 8 in either of them. So you cannot have 3 and 6 or 4 and 8. So you know this has to be 1 with 2 or 2 with 4. Either way, there has to be a 2 in one of those cells. Now remember, we said that these digits had to be 5, 6, 7, or 9. So this is similar. This is 1, 2, and 4, right? With one of these being 2. Where is this digit here? It's a 5, 6, 7, 8, 9 from what we know earlier. Similarly, this is 5, 6, 7, 8, 9. Where can it be? Where can this one be in row 8? It cannot be any of the cells in the cage. It cannot be here. So this cell specifically must be the same as this cell. So this is 5, 6, 7, 8, 9. And then it also has to be one of these cells because that's the only place for it in row 9, because we've eliminated all the possibilities here. This cell, which we'll make orange, actually we'll make it green. Where can it be in row 2? It cannot be any of these, can't be in the cage, and it can't be here because it can't be 5. This cannot be 5, 6, 7, 8, 9, so it has to be here, which means the green cell is here. So this is also 5, 6, 7, 8, 9. Whereas this cell here, this cell, we're going to make orange, has to be here. So because it cannot be in the rest of this cage here, it can't be here, it can't be here, it must be here. What about this cell? Let's mark that as blue. This cell cannot be in the rest of this cage here. It can't be here. And since this is a 9-cell cage, it requires every digit. So it must be here. So this is blue, which is different from the orange. We don't know how they're different, though. Okay. we know these cells, again, have to be 5 through 9. And these cells have to be 5 through 9. Well, and similarly, these cells are 5 through 9, these cells are 5 through 9. What does that mean? We have a 5, 6, 7, 8, and 9 quintuplet in column 1 and in column 9, which eliminates 5, 6, 7, 8, and 9 in the rest of the column. So this cannot be the gray, the medium gray. It has to be 1 through 4. Oops. Has to be 1 through 4. This is 1 through 4, and this is 1 through 4. We're going to actually mark this also as the red that corresponds to the yellow, the red 1, 2. This then must be the yellow 1, 2. This can't be yellow 1, 2, so this must be red 1, 2, which makes that yellow 1, 2, which makes that red 1, 2. This must be yellow 1, 2, and this must be red 1, 2, and this is the red 3, 4. Okay. Well, we have a 1, 2, 3, 4 quadruplet in box 7, which eliminates 1, 2, 3, 4 from the rest of the box. So this must be 5 through 9, and this must be 5 through 9. Well, this cannot be 2 because of the 2. One of these is a 2 here. We now have another, this has to be 5 through 9 also. This is 1, 2, or 4, and this is 1, 2, or 4 here. We now have another 5, 6, 7, 8, 9 quintuplet in column 2. So, and this actually is similar here. This cannot be green. This has to be 1, 2, 3, or 4, but it can't be 2. This is 1 through 4. This is 1 through 4. So these also must be 5 through 9. So in columns 2 and columns 8, we have all the digits. We have a quintuplet, which require the digits from 5 through 9, which means the rest of the column must be 1 through 4. So this is 1 through 4, these are 1 through 4, this is 1 through 4, and these are 1 through 4. This has to be a digit 5 through 9. Well, we have another quintuplet in column 5, which eliminates all the digits from 5 through 9 in that column. So this has to be 1 through 4. This is 1 through 4. Neither of these can be 2. Neither of these can be 2. Okay, because one of these has to be 2, which means neither of these can be 2. Okay. Where is the red 6, 8 in this cage? Cannot be any of these two because it sees that cell. Can't be here because it sees that cell. These are not 6. This cannot sees that cell. And actually it sees both 6s and 8s. So this can't be 6 or 8. This also sees both 6 or 8. So this can't be 6 or 8. Can't be here because this is not 6 or 8, and can't be here because it's not 6 or 8. Therefore, this must be the red 6 or 8. So now we cannot have a 6 or 8 here. This 6, 8, 6, 8 pair eliminates any 6 and 8 from the rest of the cage. So this is 5, 7, or 9. Similarly, where's the yellow 6 or 8 in this cage? Cannot be here. Can't be here because of this 6 or 8. Can't be any of these. Can't be the red 6 or 8, so this must be the yellow 6 or 8. Well, interestingly enough, this sees both the red 6 or 8 and the yellow 6 and 8, so this cannot be 6 or 8. So we have 5, 7, 9 here, 5, 7, or 9. This cannot be 6 or 8. This can't be 6 or 8. So this gray is a 5, 7, or 9. So it still could be either of these. This green also has to be a 5, 7, or 9. And this also sees both 6 or 8, so this has to be a 5, 7, or 9. Hmm. Where in hmm. This also sees both 6 and 8s because it sees red and yellow 6 and 8, so this can't be 6 or 8. Similarly, this sees both red and yellow 6 or 8, so this can't be 6 or 8. Hmm. So the yellow 6 or 8 could be one of those two. The yellow 6 or 8 could be one of those two. Hmm. The red 6 or 8 could be one of those two. The red 6 or 8 could be one of those two. Hmm. Okay. Let's see. Oops. This green has to be one of these two greens, but we're not sure which. In this cage. This medium gray has to be one of these two medium grays. This is 5, 7, or 9. Huh. Okay. Hmm. Where? Hmm. One of these two must be the yellow 1 or 2. So either this is the yellow 1 or 2. So it's either here or it's here. We're not sure which. The red 1 or 2 is similarly one of these two cells. And therefore is either here or here. We're not sure which. Oh, this is also okay. These are both yellows. These are both red. One, two, three, or 4 because these are the yellow 1, 2, 3, 4. These are both yellow 1, 2, 3, 4 because these are both red 1, 2, 3, 4s. So these must both be red. So these are the red equivalents. We're not sure which ones. These must both be yellow. But we don't know which one. It's either 1, 2. So this has to be a yellow. This has to be a red. Because again, both yellows 1, 2, 3, 4 have to be here. This has to be the yellow 1, 2, 3, 4. This is the red 1, 3, or 4. We're not sure which. Um, Okay, I see it. If this were the red 4, it would have to be with 5 and 6. And the 6 would have to be the red 6, right? Because we have the yellows of both 3, 4, and 6, 8 in that box. So if this is the red 4, that would mean this has to be 5 and 6, and the 6 would have to be a red 6. But it cannot be that case because 4 and 6 are not in a 1 to 2 ratio. Hence, this can never be 4. So this could be 1 or 3. But if this is 1 or 3, being odd, these can never be. This is already odd because it sees both 6 and 8. If this is odd and this is odd, if this were an even, that would add up to an even digit because you have 2 odd digits and 1 even digit. That adds up to, because you have an even number of odd digits, that adds up to an even digit. So this can never be even. It has to be odd. So that we now have a 5, 7, 9 triplet in box 3, which eliminates 5, 7, and 9 in the rest of the box. This cannot be 7 or 9. This has to be a 6, 8, and this is a 6, 8, 6, 8 pair. This can't be 6 or 8. These can't be 6 or 8 because they're in the same cage. This can't be 7 or 9 here, and these can't be 7 or 9 here. So where is the red 6 or 8 in box 1? It has to be here. So this is red 6 or 8, which means this cannot be red 6 or 8. These can't be red 6 or 8. This can't be red 6 or 8, so this must be the red 6 or 8. Now this could be 159 or it's 357. We don't know which. Either way, there has to be a 5 here, which means this cannot be 5. This cannot be the red 6, 8, so one of these two is the red 6, 8, but we're not sure which. Red 6, 8 cannot be here, cannot be here. Where is it in box 6? It has to be here. So this is red 6, 8, which means this can't be red 6, 8. So this must be the red 6, 8 here. So we should have all the red 6 and 8s. This can't be red 6, 8. This can't be red 6, 8. So this is the red 6 and 8. This is now 5, 7, and 9 because that's the only digit remaining. The yellow 6 or 8 could be here. We're not sure. If this is 1, this has to be 2, 4, which makes this 3 and 6. So if this is 1, this is 4, and this is 2. Right? So if this is 1, this is 4, and this is 2. If this is 3, this has to be 2, and this is not, this would be 4 then. So this would be 1. Either way, 1 has to be here, right? If this, again, if this is 1, obviously 1 has to be in the column and eliminates all 1s in the rest of the column. If this is 3, this is 4. This must be 2 and 1. And 3 has to be with 2 to add up to 5. So either way, 1's here, which means this, so 1 is one of these two cells. Oh, this then must be 1 or 3, right? So 4 has to be one of these cells. This cannot be 4. This is 1 or 2, which makes this 3 or 4 here. So this is this then has to be the yellow 1 or 2. This is the yellow 3 or 4. Huh. This cannot be 1. This cannot be 1. Hmm. What about these? If this is 1, that would mean this is 8 and that's 9, and that works. Because then this would be 4, this would be 3 and 6, and that's fine. If this is 3, this would have to be 7 and, no, 6 and 9. So this would be 4 and 8, so that works too. If this is 4, this becomes 3 and 6. This would then be 1 and 2. Wait, okay, so if this is 4, this becomes 1. This is 3, this is 2. This would be 6. So if this is 4 and this is 1, this has to be a 1 then. We can remove the orange here because we know this is specifically the yellow 1, 2. So if this, again, if this is 4, this would have to be 1. And this would be 3 and 6. So this would have to be 1. This would be 2. This would be 3. That seems fine. Ah. Interesting. Okay. One thing we didn't know is in column 9, where is the yellow 6 or 8? It cannot be any of these. Can't be any of these. It has to be one of these two. We also know there's a yellow 6 or 8 in this 30 cage. So 1, 6, or 8 has to be in row 7, row 6 and 7. This 6 or 8, yellow 6 or 8 in column 9 has to be in rows 6 or 7. Therefore, there cannot be another yellow 6 or 8 in the rest of row 6 and 7. So this cannot be 6 and 8. Where is the yellow 6 or 8 in column 5? It has to be here. So this has to be 6 or 8. This cannot be 6 or 8 because of the 6-8 pair. So this is 5, which means this can't be 5. This can't be 5. This is a 5 here. This can no longer be 5. That doesn't help us much. If this is a 6 or if this is the yellow 6 or 8, where can it be in box 7? Can't be here because it's in the same cage. None of these are 6 or 8. Can't be any of these. Can't be here because of Sudoku rules. So if this is 6 or 8, that would eliminate 6 or 8 in any of box 7, which is not allowed. So this has to be not 6 or 8. This has to be 7 or 9, which means we have a 7, 9, 7, 9 pair in column 2, which eliminates 7 and 9 in the rest of the column. Therefore, this is 6 and 8 and is the yellow 6 and 8. Which means this is the gray 5, 7, or 9. One of these again. This cannot be 6 or 8. This has to be a 7 or 9. We have a 7, 9, 7, 9 pair now, which eliminates 7, 9 from the rest of the cage. This must be the yellow 6 or 8. Therefore, this can't be the yellow 6 or 8. It must be a 5. Where now is the yellow 6 or 8? It has to be this cell. So this is the yellow 6 or 8. Which means where is the yellow 6 or 8 in column 7? Cannot be here, cannot be here, can't be either of these, it must be here. So this is the yellow 6 or 8. This can't be 5, so none of these cells can be 5. This is an even digit with an odd digit. To add up to an even digit, you need another odd digit, so this cannot be 4. So similarly, this is 2 or 4. This red, oh, we always knew this had to be 1 or 2. Interesting. So this is the same, right? Because we know these are reds and they add up to each other. So this has to be the 1 or 2. This can no longer be 1 because one of these has to be 1. This can no longer be 1. So this is 1 or 2. One of these is 1, so none of these can be 1. Similarly, one of these is 1, so none of these can be 1. This can no longer be 5. Therefore, the greens are 5. So this is a 5, this is a 5. This can no longer be 5. One of these is a 5. We already knew that, kind of. 7, 9, 7, 9, 7, 9. So whatever this one is, okay, so we're going to mark this as blue. This cannot be the blue one. It has to be the medium gray, which makes this the blue one. This can't be 7 or 9 because of the 7, 9 pair in the row, so this must be a 5, which means this can't be 5, so this is a 5, and that is the green. We don't know which ones these are, so that's not helpful. This is a 5, this is a 5. This can no longer be 5. This has to be the 5, and therefore is the green. So this can't be green. This can't be 7 or 9, so this must be 5. This is the blue 7 or 9. Where is the last blue 7 or 9 in row 9? It has to be here. So this is the blue 7 or 9. This can no longer be the blue 7 or 9, so it's the gray 7 or 9, which makes this the blue 7 or 9 here. Whoops. Where this has to be a blue 7 or 9. This cannot be 5, so it's the gray 7 or 9. This can't be the gray 7 or 9, so it's the blue one, which makes this the gray 7 or 9. This has to be the blue 7 or 9 here. Where is the blue 7 or 9 in box 4? It has to be here. What else do we have remaining? 5. 5 cannot be here in box 5. It has to be here. So this is 5. We should have all the 5s then. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can remove the green from it. This has to be the gray 7 or 9. Oops. So this must be the gray 7 or 9 because that's the only place for it. This has to be the yellow 6 or 8. Okay. If this is 3. This would have to be 6 because this would be 4 and 8 here. So if this is 3, this would have to be 6. This would have to be 9. But then this would have to be 7, and that would force this to be 3. And then both the red and the yellow would be 3. So that can't be the case. Therefore, this must be 1. Excuse me. Which makes this 4. This has to be 1 then, also. All the yellows are 1. This can't be 3 or 4. This has to be a 1. And this is a 1. That forces this to be 2. This is 3. This has to be a 6. This is 8. This has to be 9. Which makes this 7. And this is a 3. Which makes that a 2. That's 3 in the corner. We celebrate because we can now disambiguate everything. This is a 4. This cannot be a 2. This cannot be a 2. So this is the red 2, 3, 4, which makes this the yellow 3, 4. This has to be a red 3, which makes this the red 2. This can't be 2, 3, or 4, so this must be a yellow 1. This can't be 1. This can't be 2, so this is the yellow 3, 4, which makes this the red 2. So this is 2. That means this is the yellow 4. This has to be the red 3, 4. This is the red 3. Okay, so we should have all the 1s. Let's get all the 1, 2 pairs. So those are all 2 now. When we have all those, we should have yellow 3, 4, but that's problematic. Okay, so we can remove all the 1s from coloring. We can remove all the 2s from coloring. Oops, not the digit. So we're going to mark the 3, 4s. Actually, let's mark the yellows then. So those are all 4. We can remove the yellow from the 4s. So all the yellows now have to be 8s. So these are all 8s. The blues are all 7s. And the grays are all 9. The remaining 3, 4s are 3s. These are all red. And the remaining 6, 8s are all 6s. And that should be the solve. Congratulations, you got the solution. More puzzles coming soon. Very cool. Very interesting, actually. I liked how this interacted very much. Particularly sort of dividing up the 1, 2s, 3, 4s, and 6s, 8s, where they had to be. And actually, you also had to divide up the 5, 7, 9s, which was very interesting also. So, very well done. Very well done job of setting. Good job of getting the instructions spot on. And I hope you enjoyed this solve of this puzzle. And I'll see you next time on Frank Puzzles. Take care.